The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees.
Thank you very much for that kind introduction. What I'd like to do today is tell you a little bit about our work with self-consolidating concrete in the Virginia Department of Transportation. And then I will try to concentrate on beams. And when we talk about beams, it will be both the normal weight and the lightweight beams. And then I will try to tell you a little bit about the lessons learned. The first structure we built, a bridge structure we built in Virginia, is this arch bridge. They call it the Bibo arch bridge. And it had 5,000 psi strength and low permeability concretes. The way we made those arches was we had the form placed sideways, an arc length of 45 feet, and one person was able to place this whole arch in the plant. So it was a very good application for us in 2001. But what we saw here in this first project, that we were getting sometimes some surface blemishes like the bug holes or the sand streaks, and there was some slump flow variation, and we also noticed that the self-consolidating concrete is sensitive to materials, and Carolyn indicated the important the water sensitivity, and we needed a good quality control. Now, as you see here, this is the case where you have the sand streaks. It usually happens in the higher workability, higher slump flows, and when we tried to reduce the slump flow, then we ended up with some bug holes on the surface. So we had to be careful. And then in 2007, we placed SCC in drill shafts. And as you know, these are deep holes, and it is not possible to consolidate concrete in these drill shafts. And what we noticed in this project that self-consolidating concrete was very easy to place. And the contractor liked the idea that he was able to remove the casing easily. You see, sometimes they say that it's an issue to remove these casings. It gets stuck, so you pull the whole thing. So he was very happy about that. So we liked that as well. And then after this project, we included the self-consolidating concrete as a requirement in our drill shaft special provision. So now every drill shaft in Virginia is done by self-consolidating concrete. And then we also placed in pier caps in 2014. We placed in pier caps. And what we noticed here is that they wanted some, this is a ready-mix truck bringing to the job site. They want a little bit more working time. So they put a retarding admixture into this mix. And then we noticed that this extended set time made the finishers very unhappy. So we took it out, and then we used a regular water-reducing admixture, and then they were able to finish on time. And then another good application for us in the bridge structures is the substructure repairs. And we started this in 2010, and this is alternative to shotcrete. And we initially worked on two projects, bridges. One is a pretty small bridge here on Route 699, and then the other one is on Route 712. So this was our 2010 first experience. The same ready-mix plant provided the concrete to both of these projects. And what we noticed, this is the very first structure we did with the bridge structure as a repair. And what we noticed, very sharp corners in these support buttresses. And that was very interesting to people. So that was and also a very good finish like the other speakers were talking about. And then we started doing the second bridge. And here what we notice is the importance of securing these formwork to the structure, because we were having some bulging, and therefore they tried to put more 2x4s and secured it better, firmly into the structure. Another thing we noticed there is that we wanted to close all the little holes because this material could easily run out of it, type of thing. So these were some little lessons we learned during these projects. One other thing we noticed is that you need to have some kind of head to move this material. You can pump it, or you have to use some system, very simple system like you do. This height provides some head for us to move the SCC. That turned out to be another important issue for us, need head pressure. And as you see, we have used different pumps. And you can use this trailer pump, a simple pump, to pump this SCC. So it's not a concern these days. Now, one other thing we noticed in this project was that we need to maintain the flow of SCC during the construction. Because most of the time, the test, ASTM test done in the first 5-10 minutes, but what we are interested in is what happens to this concrete during the construction. And what we noticed in some of these early jobs is that they had to have the handheld vibrator to move this stiffening concrete. So we did notice some slump loss, but then later on we started using the retarding admixtures or hydration stabilizers or the workability retaining admixtures to keep it SCC during the construction. So that's what we emphasize these days. It's okay to test early, you need that, but you also need to make sure that it is SCC during the job. So in some jobs, I did test it as the truck was leaving the project to make sure that it was still SCC. Now let's come to the beams. The beams have congested reinforcement, as you see here. A lot of reinforcement in beams. So we like this concrete to flow easily because these are the things that we can see. This is again one of our projects. What you see here, this is the bottom of the beam. And when you have a close-up here, you see that there are a lot of honeycomb, large air pockets in the system. This is a pre-stressed beam. And it was so interesting that in this beam, probably like 70, 80-foot long beam, only in this section you had corrosion. Why? Because that's the area that you had the consolidation problem. The rest of the beam was in good shape because it was probably had a better consolidation. And then another thing we see, for example, this is the end of the beam, and we are also seeing some consolidation problem right there with the regular concrete. So that makes us feel comfortable with self-consolidating concretes to fill those voids type of thing. So what we did in 2003, test beams. So we made a test beam. This is a 45-inch deep beam that they use in the structure, that kind of cross-section in the real structure. And this is a 60-foot long beam. We wanted 8,000 psi minimum to an 8-day strength and 1,500 coulomb as a maximum permeability number. And then we took 2 beams to the Federal Highway Administration Structures Lab, and we tested them to make sure that we did not have any problems, because some people were talking about bonding and those other issues, but we never had any issue. These beams did very well in the testing type. So that made us feel comfortable. So in 2005, we put 8 beams. We started with 8 beams, one span of this bridge, Route 33 bridge. It's a pretty long bridge. And one span, we said, let's try SCC. And now it's very interesting to notice that these beams were well done, and the contractor, and we paid for it because it was a work order to put these 8 beams as because of a work order, cost more to us. But then the producer liked it and did 32 more beams, left beams, without any charge to the department. So they liked it. Like you are saying, Carolyn, it can be a good thing. Cost is not an issue type of thing. So this was a good experience for us. Now, let me tell you a little bit about the mixture proportions. As you see, regular SCCs have usually like 850 pounds of cementitious material. That's pretty common. And now my interest in some of these work is these eco SCCs, I don't know, where you only have 530 pounds per cubic yard. So that's what we will be discussing hopefully tomorrow in the session on SCC. Please come for that. Now, the water-cement ratio is low, like it was shown before. And then we use smaller size coarse aggregate here, 3/8 And here, as you see, 68 3/4 inch. So you use smaller aggregate in the SCC, easier to keep it stable. Now, what we noticed in this project, this again, 2005, one of our early projects, what we noticed is that there was some slump variations, and when we had it at a high flow, slump flow, we were getting these frothy, small bubbles on the surface of the top of the beams. But when we reduced the slump flow, it went to the other extreme, then we were getting these bug holes. There's no, as you see, frothy appearance on the top, but on the side of the beams, we had more surface blemishes, these bug holes type of things. So you need to, again, optimize and watch these things. And the release strength for that particular project was 4,800 PSI. In these beams, we are interested in one-day strength. In this project, initial project, they went with 4,800 PSI release. In the future projects, I'll tell you, 6,000 PSI was the release. So in one day, we get 6,000 PSI. And then SCC did maintain that easily at that project. Now, when we look at the strengths, we got very good strengths because, as you know, it has a lower water-cement ratio than the regular concrete. But when you look at the elastic modulus, even though it has a higher strength, and people relate modulus to the strength, but again, the aggregates also play an important role in this. We had similar modulus, but elastic modulus, but the strength was higher in the beams type. So that's what I was trying to do. And then the permeabilities were very low. You see that 1,000 and less is a very low permeability. So we don't have any problem. Then we went in 2013 and made 220 normal weight SCC beams. In between, there were others done, but these are the ones that I actually went and sampled, tested, and 220 beams here in this project in the eastern part of the state. And then again, a pretty rich mix, as you see here, 850 pounds of cement, and a low water cement ratio. And then as you see, coarse agate, fine agate, pretty close to each other in proportions. And this one had a release strength of 6,000 PSI in one day. And when we look at it, the surface was better in SCC versus the regular beams that they were doing at the plant at that time, conventional workability. Now, what we noticed was that we were really doing well. Look at the one-day strengths. One-day strengths were about 7,000 PSI with that mix, and then the 7-day strengths were over 9,000 PSI, and we were looking 28-day strengths of 8,000 PSI. So we got very good strengths, and then the permeability on 5 specimens were 270 coulombs. Very, very low permeability. And as we said, these are the things. One other thing I'd like you to notice is the standard deviation. In the earlier jobs, we were showing some variability, but out of these 220 beams we made, and when we tested them, we had a very low standard deviation, 310. So it was very well done. So we were happy, which means that we are progressing and doing better with our self-consolidating concretes. And now, let me tell you a little bit about the lightweight. 2006, we started doing lightweight. Again, we tested a beam in a laboratory and very good results. What we noticed when we were making this beam at the plant, that slum retention was an issue. We were losing slum fast. Again, these are many years ago. Now, I'm sure we'll do better. And now we did a bridge in 2012 and to use this self-consolidating concrete lightweight, and these have 128-foot spans, 4 beams per span. And when we look at it, it's a very nice workable concrete, and I hope, Mr. Bui, you will like this look of this lightweight concrete. And what we were having, as I told you, we were having slump loss issues, problems, slum retention, but in this project, the batch plant and beam molds were adjacent to each other. So we were able to empty this into the beam in 4 to 5 minutes. So that worked well. So either you use admixture or time, work with time issues. So we had no problems. But what we did is, especially on the surface, to make it flow easier, because we don't have much head pressure there, they use internal vibrators. And to keep the surfaces free of blemishes or minimal blemishes. They did a little bit of the external wiping, but very like 1 to 2 second type of thing. And now when you look at the mix design, again, it's a pretty rich mix and a very low water-cement ratio, and with the 6,000 psi. This is a lightweight SCC with a 6,000 psi release strength, as you see. And what we noticed is that the average 28-day strength of the lightweight concrete, so please pay attention to that, is 10,000, almost 11,000 psi in that product. So it was very well done. It was a very good, and then the permeability is less than 1,000 coulomb. So this is a beautiful bridge, beautiful beams in that particular bridge. And now our current VDOT specifications includes the self-consolidating concrete. We have a slump flow of, in our spec, 26 plus well minus 3 inches, but it can vary with applications. For example, in drill shafts, it is 23 plus well minus 3 inches. And then we look at the slump flow minus the J-ring and try to keep it less than 2 inches. And for stability, we look at the 1610 static segregation index of 15% or less type of thing. As a conclusion, we are doing self-consolidating concrete with high workability and stress factor strength and permeability using normal weight and lightweight aggregates. But we are noticing that SCC is sensitive to materials like we mentioned, the water and mixture proportions, and slump loss can occur, so flow characteristics can be maintained during construction through workable retaining and retarding admixtures. This is a very important issue for us. Not only what you do in the first 5-10 minutes, but try to see that it is SCC during the whole production. And we like stable mixes, and we can do that with proper mix design, having sufficient fines, as was mentioned here, and using the viscosity modifying admixtures. And we noticed that forms should be strong and tight. Fortunately, in beams, they use the metal, steel metal forms. They are pretty sturdy, so we don't have any problem with the beam production. But in other work, we do pay attention. And head pressure is needed for flow through tight and congested reinforcement. And thank you very much for being here.